Hello and welcome to the world of astronomy. I hope all of you are doing good. Have you ever thought why anything left from a height falls back on the earth? Why the earth attracts everything towards it? Why, whenever our legs slip, we fall on the ground? Why can't we jump or fly? The answers of all these questions are related to the things in astronomy. Let's take a ride in the world of astronomy with me. In the year 1665, when Newton was calculating and studying about motion, it is the time is said the incidence of falling of apple is said to have happened there. It prompted Newton that why the apple fall on the ground, why everything falls down on the ground, why the apple did not go up. Is that the same thing which governs in the universe, which governs the planets, which governs the motion of moon around the earth? Newton conjectured and grasped everything and found a relationship, a common thing between everything, that we know whenever we have to change the motion of an object, we need a thing called motion. We need a thing called force. Whenever, if you want to change the state of an object, you would need force. Why anything falls on ground? Because the earth attracts that. In the same way, that object also attracts the earth. But why can't we see the earth moving? The object, if we leave the object, it falls back on the earth. Why does not the earth move upward? According to Newton's second law of motion, the force is directly proportional to the momentum. The more is the mass, the less will be the momentum. Is that the same thing which governs the motion of moon around the earth? If the earth is attracting the moon, if the earth attracts the moon, does the moon attract the earth? Why can't we see the things coming towards each other? Why does not the moon come near the earth day by day? You can illustrate this by an example. Take a stone and tie it with a string and try revolving it. The stone starts revolving with the length of the string and make a circle. As soon as you leave the stone, as soon as you leave the string, the stones go away in a tangential direction outwards. But why the stone is not going away when you are keeping the thread in your hand? Or there is some force which is keeping the stone in a balanced position. This is called a force, centripetal force, the force which seeks the center, the force which tries to come towards the center. In the same way, the moon revolves around the earth, and the string-like thing, invisible force which is attracting the moon towards its center, is the force of gravitation, and due to it, the moon is revolving around the earth. If you throw a stone, it will fall back on the earth. If you throw a stone perpendicular to the surface of earth, it will come back perpendicular to the surface of earth. if you make a kind of horizontal throw, if you throw a stone in a horizontal direction, the stone will be back on the earth after covering a distance. But what if you throw that stone with a very large velocity, that it will try to come back to the earth, but it will not, just because it will be kept in an orbital motion. In the same way the earth is attracting the moon is trying to come towards the earth, the moon is falling towards the earth. But as it falls towards the earth, it moves in a circular direction and revolves around it. And this is the same reason why all the planets are revolving around the sun. And this force is not present or not permitted just on the earth or on this solar system of ours. This force is everywhere. According to the argument that Newton argued, that this force is everywhere. Not only two objects attract each other in the universe, but every object in the universe attracts every other object. And this force of attraction is directly proportional to the product of their masses, and inversely proportional to the square of the distance between them. If you take two objects, A of mass ma and B of mass mb, and there is a distance d, so that F is equal to G times ma times mb divided by d squared. In this equation there is one more term G, which is called constant of proportionality, and its value is 6.673 into 10 to the power minus 11 Newton meter squared per kilogram squared. The value of G was calculated by Henry Cavendish after the discovery of this equation with a very sensitive balance. There is one more thing related to the gravitation on Earth. If you leave two objects from a height, one a kind of feather and another a stone of mass 5 kg, if you leave them from a certain height, the stone falls faster, but the feather comes later. We generally think just because the feather is lighter in weight, and that is the reason. Earlier, scientists too demonstrated the same thing. But as Galileo mentioned in 1610 that both these things must fall with the same rate, and there is something else which stops the motion of or slows down the motion of this feather. That is the air present in our atmosphere. Instead of taking a feather, if you take a pin of the same mass, suppose 0.05 gram, and leave that pin with a stone of 5 kg from a distance of suppose 500 meters, both the things will fall with the same rate. There's one more thing. Does the velocity increases when they are left from a height? The answer is yes. According to the equations of motion given by Newton, that if there is any change in the velocity, there must be some acceleration. And if both the things are falling with the same rate, so there must be the same acceleration on this planet Earth. Does it depend on the mass? No. That is the reason why a ball of 5 kg falls with the same rate as the pin of 0.05 gram. With the calculation, we get the value of g, small g, called the acceleration due to gravity of Earth, or simply acceleration due to gravity, that is 9.1 meters per second squared. It is a constant term and does not depend on the mass of the object. But yes, it does depend on the mass of the Earth. That's why the acceleration due to gravity is 9.81 meter per second squared here on Earth. But it is not same on the moon, just because the moon and its mass is roughly 1/6 than that of the Earth. So the acceleration due to gravity is reduced by a factor of 1/6. If you want to feel weightless, if you want to lose your weight, go on the moon and weigh yourself. You'll have less weight of yours. But there's one more thing that is related to weight and math. We generally weigh ourselves and we say, this is my weight, suppose 65 kgs. But the unit of weight is not kgs. The unit of weight is Newton. Why? We'll be with the next video. Thank you. Till then, please like, share and comment. Have a good time ahead.